Lipid modified proteins. Okay, lipoproteins. Basically what you're doing here is you're attaching a lipid, and this will anchor the protein to the surface of the membrane. Okay, so we've talked about two-dimensional diffusion in the membrane. Okay, so here's like one leaflet of the membrane. Okay, there's my fatty acid chains on the phospholipids. Okay. All right, so what you're doing is you've got a protein and you added a little lipid chain to it, and it now anchors it. So it anchors the protein to the surface of the membrane. And we've got different ways to attach the lipid to the protein. Okay. So the first is N-myristoylation. So you're adding a myristic acid. Okay. So you attach a myristic acid. So we've already been through the nomenclature here. Myristic is 14,0. Okay, and this is attached to the N-terminal glycine of the protein. So it's the N-terminal glycine. So here you've got, again, your protein chain. And so this last amino acid, the first amino acid is your glycine. And so this is the rest of the protein out here. And you're going to add a myristic acid to this. Okay, now myristic acid is 14 carbons. This is an amide linkage, so don't forget your carbonyl. Don't forget the carbonyl. So 2, 4, 6, 8, 10, 12, 14. And again, this is my glycine residue. And here's the rest of the protein. And again, this will anchor into the membrane. So now it can diffuse fairly rapidly 2 dimensions, and it stays on the membrane. Okay. All right, so Merstylation. Palmitylation. So palmitic acid, drop the IC acid and add the OYL. Palmitylation. This is attached to a cysteine residue, and this forms a thioether. I'm sorry, I failed to point out, this should be obvious that this is an amide linkage or an amide linkage to that N-terminal glycine. Okay, so here we're going to form a thioether. And this is, again, attached to a cysteine somewhere in the chain. So here you've got a cysteine, and you add a palmitic. There are other fatty acids that you can attach, but palmitic is the most common. And here, again, if you're attaching a fatty acid to this, okay, and I'm going to shorthand notate this because I don't have much room left. 16 carbons, I need 14 right there. Okay, so this is a thioester. Excuse me. It is early in the morning. And thioethers is my next topic. So sorry. Thioester. This is an ester where the oxygen has been replaced with the isoelectronic sulfur. So this is your thioester. Okay. And again, you've got a long hydrophobic chain that's going to insert into the membrane. Prenylation. Okay, and prenylation, you're going to attach a prenyl group to a cysteine that's near the C-terminus. It's 4 residues from the C-terminus, okay? And then we're going to cleave off that. So what is a prenyl group? Prenylation, you've got a prenyl, there are different prenyl groups. These are formed from isoprenoids. Or from isoprene to make isoprenoids, okay? And isoprene is 2-methyl-1,3-butadiene, and this is known as isoprene. And nature uses this to make all kinds of things, including cholesterol. Okay, so the isoprene is your 5-carbon unit, and this is frequently used to make all kinds of things. Could spend a lot of time talking about this. But basically what we're doing here is we are polymerizing. Okay, so if you polymerize this, and I'll show you kind of a pseudo mechanism of this, so you get an idea how to draw the structure. All right, so what we're doing here is we are polymerizing it, so something adds here, and then this continues on, okay? I left off my double bond. Oops. And so, again, polymerization. Now, if you attach 3 of these together, well, let's say 2 of these together. 2, you have a C10 unit, and this is known as a geranyl group. If you take 3 of them and put them together, again, because they're 5-carbon units, you'd have a C15 group. This is called a farnesyl group. All right, if you take 4 of them together, you've got 20, and they call this geranyl because you got 2 of the C10 units. Geranyl. They could have come up with a better word, I think, but that's what it is, okay? And so what you're going to do is, these are the ones that we use. You attach a farnesyl or a geranyl. Okay, so you do a farnesylation or a geranylation to a cysteine to form a thioether. All right, so here's your cysteine residue. And again, this is near the C-terminus. And so I'm going to write, in the old days, the textbook said AAX. Most of the textbooks now are saying XXY. And so these can be variable in composition. Okay, so these can be varied XX, okay? But the Y, the identity of this, so the identity of the C-terminal amino acid determines if it's C15 or C20 is added. I'm not going to give you the list of which amino acids correlate with a farnesylation and which amino acids correlate with the geranylation. We're just going to say that the identity of that C-terminal amino acid determines if you add a farnesyl group or a geranyl group. So we're going to add the prenyl group, whichever one it is, okay, and again, this is a thioether. Okay, so 1, 2, 3, 4, 5 carbons. There is your repeating unit. 1, 2, 3, 4, 5 carbons. 1, 2, 3, 4, 5 carbons. 1, 2, 3, 4, 5 carbons. And when you polymerize this, notice where the double bonds go. Actually, I'm going in the other direction here. But the double bonds, if it was here and so if it was here and here, then the double bond should be there. Okay. All right, so make sure I got the right number of carbons here. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. I've got 15 carbons. All right, now you cleave off the tripeptide. So you cleave the C-terminal AAY, and this gives you, again, a cysteine at the C-terminus, and then it is methylated. So it's methylated to form a methyl ester. So your C-terminal amino acid now is methylated. So you got a methyl ester at the C-terminus. And I'm going to write the prenyl group a little differently now. Okay, so my double bond is here. And I'm going to repeat this again 3 times. And I'm sorry, I'm looking at this going, okay, I did this correctly, all right, and that's supposed to be a hydrogen, and I'm looking at this going, oh, I got these extra double bonds in there that aren't supposed to be there. When I link these, I'm making a single bond, and I got it in there as a double. I'm so sorry. So let me go back and erase that, and then I'll have this correct. I was looking at that thinking, that looks a little strange. So no double bonds right there, okay? So 1, 2, 3, 4, 5, 1, 2, 3, 4, 5, 1, 2, 3, 4, 5. The double bond is in front of the branch. Now, last point, this is a thioether. So my thioether is right there. Again, it's an ether where the oxygen has been replaced with the isoelectronic sulfur. And here is your methyl ester that's at the C-terminus. All right, so in past textbooks would devote an awful lot to this. Most modern textbooks just give a couple of pages to this. The last one I'm going to squeeze in on this page is what's known as the GPI anchor. Okay. Stands for glycosyl phosphatidyl inositol anchor. Oh, okay. So basically, this is attached to the N-terminus. And this is very common in eukaryotic protozoan parasites. It's where you find a lot of this. You find it in other places too, but basically, so here at the N-terminus, and I'm not going to do a full structure of this, okay? So here's your protein. And at the N-terminus of this, you've got a phosphoethanolamine. So there's my abbreviation for the phosphoethanolamine. You've got a tetrasaccharide. It's 3 mannoses and a glucosamine. And then you've got your GPI, your phosphatidylinositol. So again, you got an inositol, and I did not give you the structure of inositol. It's a 6-membered ring, and here you've got your glucose or your glycerol backbone. So there's an oxygen here, but this is your, actually there's a phosphate right here, excuse me. So here's your phosphatidylinositol, all of that. See why I didn't give you the full structure of this? This is your phosphatidylinositol. And this is your glycosylation. So there's your glycosyl group. Okay, so what's the difference here? You got 2 fatty acid chains that anchor it to the membrane. So here's your protein, okay, and I've got 2 fatty acid chains that anchor it to the membrane. Again, very common in protozoan parasites, okay.